Hi there, you're watching the Aussie Boom Guru, and today I'm running through the fourth part of a family mini-series that I've been running dealing with building a table as an example. So today we're going through part 4, which is the graphical settings and adding some final touches to the family. So previous sessions we've looked at planning a family, setting up reference planes, geometry and constraints, assigning parameters and formulas and coding to those as parameters. And then now we're looking at the graphical settings and final touches, and there's some advanced techniques we'll cover in later sessions. So I guess the workflow that we've run through is a 4-part workflow. It's really the method, the framework, the system, and today, the polish. So this is today's session. So currently from part 3, where we left off, we've modeled our family in 3D on the left, and then we've also added parameters and type values to it. So things such as materials, dimensions, and then grouping parameters and coding parameters. And what we'll be doing today is adding some visibility parameters first. So this is basically the framework we've set up. We've set up the bones of the family in the reference plane, the brain is the parameters, and today we're doing the skin or the appearance of how it looks and how we can make it graphically work, so making it presentable. So the first thing we're going to look at is how we can make the table fold in 3D on an instance basis. So you can see here what we're aiming for on the left. We want to be able to fold down either the left or the right side independently, or have them both folded up at the same time. So we've got 2 options for how we can do this. The first option is much easier. The second option is more effective but much harder. So we'll look at option 1 first, which is to model open and closed in 3D separately, and then use visibility parameters to toggle between them. So technically they're always both there, but we're basically just showing one or the other at once. You can never see the 2 at the same time. The more effective option, which is harder, is to model it as a nested family and control its angle in the family instead. So we'll look at that as well very briefly, but I won't run through it because it takes a little while to set up. Okay, so without further ado, let's actually go and set this up. So this is our table where we left off previously. I've went one step further ahead since last time, which is to add a copy of the folded table leaf in the closed position. So I've basically just set up some reference planes, basically one here, which is the same width as the table. I haven't modeled the strut in this position. I could if I wanted to, but it's probably not necessary given you can't really see it in floor plan or 3D because it's covered by the table. So ideally what we need to do now is assign some visibility parameters to these elements. So we need to assign visibility parameters to this first. So this is our left side, we'll call it. So we need to nest in a parameter here, and we're going to say left side open. And I'll just copy this so I can paste it into another one. And we'll make these visibility parameters. And then this will be left side closed. And we'll put this under other, because this is going to be a toggleable relationship. So we only really need to control one of these in order to adjust which one is shown at the one time. Because if one is on, the other will be off. For this one, we're going to do right side open. And we'll make that a visibility parameter. You'll recall from my last session that I tend to put parameters that the user isn't editing under other to keep them out of the way. So that's why I'm putting some of these under other, because I don't want them to be in the user's way visually when they're working. So what we have at the moment is 4 toggles that we can adjust. So we've got 1, 2, 3, 4. I'll just move that down. These 2 buttons can move the position of parameters. I didn't show that in my last session, but it's quite important to know. It's been around since I think Revit 2018. Originally it was just all sorted alphabetically. Okay, so let's just say if left side is open, then obviously it can't be closed. So closed is going to be not left side open. And what this does is as I flip between these, you'll notice that that toggles that cell. Likewise, we can do the same, not right side open. And you basically have a mixable relationship between these 2. So if I toggle this on, and what I'll do is I'll go into preview visibility mode, which shows what the family will look like. You'll see this is how I can achieve it. The one thing I forgot is to actually assign to the struts as well. So these are only going to be on when it's right side open and left side open respectively. Okay, so you can see that that's really easy, and because these are instance based, the user will be able to do it on an instance basis, and they could do both sides closed as well if they so chose. So that's really easy. That's the easy method. Obviously it works in this case because the table can only ever be open or closed. You couldn't have it open at say 45 degrees. An alternative workflow is to build a special component that is angleable on a user elected angle. So that's a little bit complicated, so I'm going to jump a little bit ahead and just show you what I've set up in order to achieve this. So if I just go to my demo folder. Okay, so if I just go to hard option, what I've done is I've built a component family that is hosted about the pivot point of the table. So essentially what this is a whole set of reference lines. So these are all reference lines. This line represents the strut in this zone. This zone represents the strut in the closed position, and this is the table with the laminate thickness on top. And you can see from there I've had to assign angle parameters between each reference line and here. So as these all adjust, so will all of these reference lines rotate around this point. And what makes this work is a reference line that tells this reference line where to be positioned, because reference lines will remain in place about a point that they're constrained to. So what I've done is I've locked this reference line's end to the junction of the two reference planes, which means that these will rotate about that point. So this is why reference lines can be more useful than reference planes in certain scenarios. And then from there I've just set a few 90-degree relationships to the ends, and then set up some dimensions and locked them down to particular sizes, and then assigned a thickness parameter. So essentially what you end up with is an angle, and then all the geometry sizes. We don't actually need this anymore, that's from what I copied it from. And then from there I've just got a visibility parameter that basically says the strut will only be in the open position when it's at 0 degrees. So if I go to, at 0 degrees. So you'll see there I've actually got two struts. I've got one this way, one that way. And if my family were to become 0 degrees, the struts would alternate and this one would be on. So essentially that's how that works. And I'll just show you how that sort of looks in the family as well. So what's happened, I've loaded these in, nested them, and I've actually nested in angle parameters to fold angle left and fold angle right. So these are essentially two copies of the same family. I've then nested in parameters to them, so things like the depth is the depth of the family, and the width, I've created a new parameter called side width, I believe. Yes, side width, which is basically this dimension, and I've actually associated the new parameter here. So what we'll do is we'll make that side width. And what that will do is parametrically connect those. So if I did make side width different, it would all adjust. And then from there, there's also the thickness of the bench top, which I've assigned. But essentially what this will do, if I were to unlock this angle and say none, I can actually go and incrementally adjust this angle as I so choose to any size that I want, which is quite effective. So eventually 90 degrees will close it. I can obviously, go way left field and do something really silly. I can go the other way. So you can see the flexibility this workflow offers over the other. But it's obviously more complicated to set up those reference lines and those relationships. From there, I've set up a formula. So I've got basically is it folded up on the left or is it folded up on the right? And the angles are basically controlled respectively by this. And then the struts are controlled internally in the family. So they just know what to be depending on what angle they're at, rather than me having to do it all at this level. So if I just fold down the right side, you'll see the strut automatically knows that it's now in the closed position. So it's a little bit more intelligent of a workflow. I definitely recommend that, if you have any questions about that, let me know, because it probably does deserve its own demonstration in itself. But that's essentially that workflow as an option. Okay, so that's how you can make the table fold. There's so many applications you can use this workflow for with toggleable relationships. It could be like opening or closing a door in 3D, for example, opening a roller shutter. There's so many options available. So have a play with that and see what you can do. Okay, so we're going to move on to 2D and 3D graphic representation. So at the moment, the family just shows its 3D geometry if I load it into a project. So that may not always be suitable. Some families can be quite complicated in floor plan when you see them, especially if they have things like curved surfaces or a large amount of line work that you may not want to show. So sometimes it is better to actually hide the 3D in certain views and draw it in 2D instead, using a combination of masking regions, symbols, lines, detail components, and detail groups. So in this case, we're actually going to hide our table in floor plan and replace it with a masking region and some graphical lines, because it's also good to use 2D lines to do what I call symbology, to enhance the communication of the family. So you can see here what we're going to add is some swing zones to show the user when they place this table, which zone is the table and which zone is not necessarily occupied by the table all the time, but has the potential to be occupied, because then if they place this family, they know they need to give it a certain amount of clearance. Obviously, it's a table, so it's not a highly coordinatable element, but we're just giving it, I guess, the most amount of potential we can. And then from here, we just need to also understand 2D hierarchy. So we're going to be using a masking region, and masking regions behave in a special way in that they will actually mask geometry that's under them. So masking regions can actually be set to a work plane even though there are 2D elements. So in this case, we're going to have a masking region set to the top of the table. And you can see here in this example, if I have a 3D geometry family, the masking region will actually block this component because its work plane is higher than the 3D geometry that it's masking. However, this element would obviously peak above the masking region if it overlaps. If I make the family out of lines instead, regardless of the work plane I put them at, they will always show over the masking region because of this natural hierarchy that Revit uses in 2D and 3D. So that's important to understand. But without further ado, we'll just go and set up some basic graphic settings. So elements in Revit have some settings you're able to apply to them in families. So I can take this leg, for example, and there's a box here called Edit for Visibility Graphic Overrides. And what this does is it gives you a lot of options for how you can show the elements. So you can actually say it doesn't show up in floor plan or elevation. Likewise, you can say that it only shows up at certain levels of detail. So what we're going to do straight away is just take everything. And we're actually going to say none of this is visible in plan. And we'll say everything shows up at all detail levels. But maybe we'll just say this is too detailed. So let's say this only shows up at fine. Let's say that the table shows up at medium and the handle shows up at fine. And we'll just show you what that means in a second. Okay, so from there, we could say that these don't show in elevation and use 2D graphics instead, but for now we'll let them show. Basically what would happen now in floor plan, if I go to my preview mode, you see I see nothing. So the reason we've done that is because we're going to actually put some 2D elements in here. So we're first going to use a masking region for the table. Just category furniture, and then we'll just make sure it shows up at all detail levels, and we'll just draw it and then constrain it to these reference planes. And essentially this becomes our graphic representation of the table instead of letting the 3D show as well. And we're using a masking region so that it still obscures things that are below it, like a 3D table would. And we'll just use some hidden lines for the swing zone of the table. So you can actually constrain ends of lines. If you hover around the end, you'll get a node snap, which can be quite effective. Alternatively, you could have an invisible line on this side of the box that you could constrain instead. That's an alternative. Whoops, I have multiple align on, so I probably should turn that off. Okay. That's one side. I'll just do one side and then I'll show you one that I finished later, just so I don't keep you watching for as long. So if I draw 2D lines, they actually understand how to snap to reference planes. So I've just drawn these two lines here and I don't need to constrain them because it knows it's meeting an intersection of two reference planes. So I've ended up changing the size of that side table. You'll see my lines move with it. So some things don't need to be constrained. They have soft snaps, as I call them. And essentially this masking region is only visible in that floor plan. However, it should be situated at the top work plane. So we'll just set that to top. And likewise, we can do the same with lines as well. So it's really important to understand that those 2D elements can have, I guess, a 3D work plane that they're associated to. And likewise, I'd also do the same in elevation. I'd do an arc. So we'll just do a 90-degree arc, and we'll just make it the size of the fold. So associate that to side width, so it's connected in parameter. And I'll just turn on the center mark so that we can constrain to here. And it's important to understand that with 2D lines, their center mark actually is a graphic thing, so you do need to turn it off when you're done. And from there, we could look at adding also the swing, just in case it's folded down, and you'll see why we do that in a sec. Okay, so they're all constrained up. Okay, so if we go preview 1, hide category, so now we actually get a swing zone, and you won't see that dimension, so don't worry too much about that. Okay, So that's some graphics you can add to your families. You could add visibility parameters to them as well. So you could say swing zone visible or swing zone not visible. Another way to manage them is to use object styles. So under manage object styles, you can create new subcategories for furniture. So let's make one called plan swings. Because currently we're just using hidden lines, which is a bit of a generic coverall sort of category. It's really just, I want dashed lines. So we're gonna actually give this a different subcategory, and that will actually give us control over those particular lines. So from there we can also go elevation swings and do the same, so we can actually add more control. Okay, I won't do the other side just to save a bit of time. So we've got object styles. You can also set up object styles in 3D as well. So I could say table is an object style, but it's important to understand that any nested component, you'll need to actually go into it as well and add the object style there, because otherwise it treats it as furniture. It won't associate it with the object style of the family. Okay, so we've got furniture, so now we can make that table. And notice too that the category changes here as well. I usually advise not going too overboard when it comes to object styles. Some people want to give a subcategory to everything. It all comes down to how you want to manage the graphics in your views. What do you need to independently control? You may not need to independently control tables, but maybe you do. It's important to use the exact same wording as well, because if I do tables, for example, and I make this tables, and I load this back into my family, you'll note that it's not going to be the same object style. There's two. This is a really common issue in offices I've worked at, where they're not consistent with plurals or singulars, or even how they name object styles in general. So they end up with double ups, triple ups of their names of object styles. You'd have to actually go there at that point and delete that. So notice that it introduced its object style to the next level. So as you can probably guess, if we load this family into a project, it will bring in its object styles as well. So it's good to sometimes load up your template with the object styles that you use, so that you don't have to rely on your families bringing them in each time. And from there we could associate that object style with the rest of our geometry as well. And we'll just load this back into our project. Great. So if I place one of these, you can see I've only got one side of the graphic swing there, because that's the only one we modeled. But in principle, that is what it is. Obviously, if you go to realistic, it won't actually show you realistic. That's one of the drawbacks of using this workflow. So it's up to you to decide what you think is best. And notice at the moment we're in coarse. If I go to coarse, the draw's gone. Medium, the draw's there. Fine, the handle's there. So it hides it. So you can make very complicated families quite easy to view in 3D by default. So there you go. So that's the folding in action. And notice it's an instance-based parameter, so it's not affecting other placements of the table. So from there, if we go to floor plan and we just create a section to look at our family front on, and then we just go fine, and there you go. So now you can see that. We'll go to 1 to 20 just so you can see I'll just double check the object style, because the object style comes into the project level at this point, and from then on that's where it's controlled from. Elevation swings is solid, that's why. Okay, there we go. And then because we've set up those subcategories, we can actually independently control them. So I can make my elevation swings a different color if I want to, for example. Or I can even hide them all together and say I don't want to see elevation swings. And there you go, they're invisible without affecting the actual family itself. And likewise, I can also turn off table, and my tables would all be turned off. So that's just a way you can also enhance the graphic control of your family. So that's pretty much it. We've built a fully functional family that does everything we'd need to do. Hopefully you've been able to follow along the whole way. So some later sessions I'll be running through will deal with more advanced techniques, specialized techniques, I guess, that you wouldn't use in every single family, but you may find use out of. For example, parametric arrays and lookup tables. So feel free to keep an eye out for those. If you have any queries about what we've covered, just feel free to leave them down below as a comment. Always happy to answer any questions you have, or take on any feedback. So thanks for watching today, and I hope you've got a lot out of this session, or this series, I should say. And feel free to tune in for future videos, and thanks for watching. Take care. Bye.